Hi, everyone. I'm Mark Rakhmilevich. Welcome to today's session on developing NFT and fungible token applications on Oracle blockchain platform. I am part of Oracle development team. I'm Senior Director of Product Management responsible for our technology. And with me, I have today Enrico Petocchi and Luca Mencacci, our partners that have developed a very interesting applications that they will share with you as we get deeper into the use cases. Now, let's get started. We'll begin today with an overview of blockchain tokenization. We'll briefly cover how Oracle blockchain platform supports fungible tokens and NFTs, share some customer examples and use cases, including the ones that Enrico and Luca will talk about, and then close with some thoughts on how we can help customers with their blockchain journey. Let's get going. I'd like to start with a basic definition here about tokenization and why it's important for enterprises. Tokens essentially are digital representation of certain assets that can be self-describing. That is, a schema used to describe them includes attributes, rights, any kind of rules associated with how those assets are to be managed. When tokens are based on a blockchain ledger, when they're recorded in a blockchain ledger, they benefit from tamper resistance or immutable properties of the blockchain and trusted transactions, which makes them perfectly suited for multi-party processes, such as trading, exchanges, and so on. And when you use smart contracts around tokens, you have programmability, meaning that you have validation rules and application-specific behavior, state transitions, and the like that are codified, if you will, or automated in code. Now, there is great forestry reports that goes into more details about tokenization principles and the benefits to the enterprise, but I'll just highlight a key thing here is that the benefits to companies are both from a bottom line perspective, namely efficiencies, process efficiencies, cost savings, fraud reduction, as well as top line benefits in increasing potentially new revenue streams, creating new business models, and helping to redesign multi-party processes to improve the access to market and reach that they provide. Now, there is a number of benefits to asset tokenization. You can use tokens to transfer ownership, or doesn't have to be ownership, really could be any kind of usage or access rights to assets. You could verify ownership history without depending on intermediaries. You can support fractional ownership, so you can increase liquidity and encourage greater participation. It makes it easier to track digital assets or digital twins of a physical asset across enterprise lines of business, business units, or in B2B transactions, or even B2C engagements. And I just wanted to differentiate here between native digital assets that exist only on blockchain versus those that represent physical assets as digital twin with a digital record that essentially has the attributes and metadata associated with some physical assets. And while traditionally that's been used in financial services, it doesn't have to be. You could have digital twins representing any other kind of assets out there. There could be equipment, there could be physical products of any sort in a distribution chain, a supply chain, and the like. But fundamentally, by using tokens, the enterprise systems can better control access and operations associated with those assets based on the metadata, based on the state and attribute information, the codified rules, and the actor who's requesting the change and the access levels that they have. Now, tokenization, of course, is something that's been around for a very long time, but it became really interesting with Bitcoin, the first blockchain, with introduction of cryptocurrency. And then Ethereum, of course, introduced programmable tokens based on smart contracts. So you now have ERC20, ERC721 for fungible, non-fungible tokens. More recently, ERC1155 that combines fungible and non-fungible tokens in a single contract, and others. And there are new emerging networks, Flow, for example, which is often used to support NFT marketplaces for collectibles, digital arts, and so on. But besides these applications, which we're probably familiar with, there has now been, over the last couple of years, a really significant uptake of these capabilities in an enterprise use cases. And we're seeing a lot of emerging use cases in loyalty and rewards programs using fungible tokens, royalty tracking, cross-border funds transfers that a number of banks are participating in. And one of the more interesting fungible token use cases recently is around central bank digital currency, or CBDC, and we'll talk a little bit about what that looks like. On the non-fungible token side, we see also use in reward systems. For example, when you reach a certain level in a loyalty program, you might be given a VIP access to certain events or certain, special tokens specifically crafted for you, and so on. But we also see it in regular day-to-day environments, manufacturing, for example. If we're talking about regulated production supply chains in food and medicine and many others, non-fungible tokens are beginning to be used to trace unique components in those supply chains. Electric vehicle batteries are also now becoming an interesting topic, being traced using what's called EV battery passports as NFTs. They have significant value beyond the time that the battery actually is useful in your cars. It could be repurposed for other equipment and then recycled and so on. And so keeping track of that same batteries through the entire circular economy processes can be significantly, helped using NFTs. In global logistics, we're beginning to see electronic bills of lading leveraging NFTs as well, because it's a negotiable document that defines who owns the products and who's got custody, shippers and carriers and freight forwarders and, customs, etc., all of that. And those documents have to get updated to a very specific life cycle. In more general supply chains, we're seeing interest in having supplier certifications or qualifications being represented essentially as NFTs as well, and a number of others that we'll touch on. Now, Oracle's approach to tokenization starts from the fact that our blockchain platform is based on Hyperledger Fabric technology, which does not have native tokens built in. However, customers and partners have implemented ERC20 and ERC721 type smart contracts as application chain code on Oracle blockchain. What we wanted to do is to create standardized building blocks so that you don't have to build this from scratch every single time. And so we use our low-code blockchain app builder tool to generate all the necessary standard chain codes that you could use to manage fungible and non-fungible tokens. And it's based on a standard called Token Taxonomy Framework from IWA. It originated from Ethereum Enterprise Alliance, and later on IWA took it over because it's much broader than Ethereum. And in the standards, there is essentially a meta model defined that has things like a base token type, whether it's fungible and non-fungible, properties, whole or fractional, different behaviors, transferable, bornable, and you can add custom properties that are relevant to the assets that you want to track. Based on that, you can essentially have this model of a token definition in a template. You can then create specific token classes and implement particular instances of those classes. So in Oracle blockchain platform, we've implemented fungible tokens first. That was last year. We've enhanced some performance with optimizations, and then released this year, earlier in this year, support for non-fungible tokens using ERC721. There is this formula in TTF that is used to describe token details. So you have things like base type, which is fungible and non-fungible, behaviors, and then additional properties that can be used to further define the capabilities of the token. You see behaviors here, transferable or non-transferable, divisible or whole, singleton. This is the one that defines whether you have a NFT token, quantity one, or some multiple quantities, which is more typical for fungible tokens. Whether it's mintable, so ability to issue new tokens. There is role-based security support in there, and ability to burn or retire tokens as well. So all of these capabilities are very important, and we provide a very easy way to specify them in a template, and I'll share that with you. So let's talk about how Oracle blockchain platform implements fungible and non-fungible tokens. But first, let's start with the platform itself. As I mentioned earlier, it's based on Hyperledger Fabric, which is an open source project under the Linux Foundation, which Oracle has been participating for a long time. But in 2017, we have joined the Hyperledger Foundation portion and started working on Hyperledger Fabric-based Oracle solutions. It became the Oracle blockchain platform, available in our cloud, OCI, since 2018. And then we also have an enterprise edition of this for on-premises deployment, was in customer data centers, even in third-party clouds since 2019. So this platform basically is Hyperledger Fabric. It's got peer nodes, which have ability to host copies of the ledger, and then smart contracts can execute there. There is ordering services, which are responsible for sequencing a group of transactions into blocks, sending those to the peer nodes for verification and so on. There is membership service, which handles identity management using X509 PKI certificates. We have added and extended this a lot with operations tooling, operations console for management monitoring, available through a web user interface, as well as REST APIs, API gateway for REST API, access to smart contracts, event subscription, and a number of other features, including orchestration in cross-chain exchanges. And blockchain app builder is a low-code tool I mentioned earlier, which enables us to automatically generate, deploy, and manage smart contracts. All of this is pre-integrated with a lot of Oracle capabilities in Oracle Cloud or on premises that are dependencies for this environment. So instead of having to build all of this from scratch, you have a ready-made environment with pre-assembled container management, high availability, identity management, integration, zero downtime patching, dynamic scaling, and the like. A lot of confidentiality and auditability enhancements, fine-grained access control, block integrity verification, and so on. Strong integration features, not only the REST APIs, but a lot of integration adapters for a variety of Oracle and third-party applications in cloud, on premises, Hyperledger, client SDKs, open source SDKs can be used as well. And of course, all of this is interoperable with other Hyperledger Fabric nodes from other vendors, whether in the clouds or on premises or open source nodes if you want to deploy that as well. And we've also done some integration to ensure we can stream the blockchain transaction history into Oracle database, which what we call rich history database schema, so that once it's in the database, the transaction gets updated asynchronously, but in real time, and you have ability to apply analytics, data visualizations, machine learning, and the like. And all of those things are helping customers to get the applications built in a record amount of time. For more information, you can visit oracle.com/blockchain. Now, when you go into Oracle Cloud, if you want to quickly play with this, if you have a cloud account, you can use a main cloud menu here to drop down towards developer services in the categories, and then go select blockchain platform. And this will pop up a screen, which is where you provision this. Very simple, a couple minutes wizard, you fill in a couple options, you click create, and this is going to go ahead and kick off the provisioning process, which will orchestrate and marshal all of the necessary resources. That includes OCI infrastructure underneath, manage VMs, block storage, security components, and the like. The actual Hyperledger Fabric nodes, so peer nodes, ordering nodes, membership service, and then chain code containers. And the add-on components I mentioned earlier, which is our console, API gateway, integration with identity management, and scale-up wizard, and all of the rest of that. So that's all created in a single environment for you. And 10, 15 minutes later, it's ready to go. You have access to a console to actually manage your blockchain instance and network. And you see the on top here, you have tabs that you can go through in this console. Network tabs to manage the network, nodes to manage all of the components, channels, which is a way to subnet the blockchain into multiple ledgers, chain codes, the smart contracts, and so on. So this gives you great ability for administration, configuration, configuring all of the details of your network, adding nodes, editing policies. You also have lifecycle management for smart contracts, whether deployed through the blockchain app builder or directly through the wizards available in this console. You can deploy and upgrade, set endorsement policies, and the like. And then monitoring, visualization, troubleshooting. You can see how peer nodes, for example, map to different channels. And then you can use Ledger Browser to go and see the individual blocks, and then transactions within the blocks as well, and all of the necessary details about those transactions. So once we have this environment, we have, since we've started, we've introduced this in 2018, we have done a lot of work to simplify and make it production ready, so customers can literally start with an environment that has everything they need to be able to take this environment, productize it in a matter of a few days, a few weeks, not only from a deployment perspective, but integration with back office systems of records, all of the security features and auditability, easy to run through this console as well as API, so you don't need a PhD in blockchain, and easy to extend new nodes to add members, whether Oracle nodes or, as I mentioned, if your ecosystem uses other clouds or other vendors' nodes, you could add those as well. But what we found over the years, of course, is that customers still need to do some work on blockchain application itself. And so there are two things that we've done to help that along. The first one is we built an ecosystem of partner solutions across various industries, from financial services to manufacturing, retail, logistics, education, healthcare, etc. But there's always going to be a need for custom solutions as well. So we have created a low-code development tool called Blockchain App Builder. And this is a tool that is used to automatically generate chain code from templates, from declarative specs. Now this can be done in general templates. You can define different objects that you want to manage and capture on ledger. It could be a shipment, it could be a purchase order, it could be a product representation, but it can also be tokens, such as fungible and non-fungible tokens. And this is how we actually support tokenization in Oracle blockchain platform, by creating tokens from the blockchain app builder. The blockchain app builder tool itself has two interfaces. You have a GUI using Microsoft Visual Studio extension, and a lightweight command line interface as well. The tool manages the entire dev, test, and deployment lifecycle, from scaffolding to testing and deployment. But specifically, the distinguishing characteristic is its ability to generate chain code, either in TypeScript or Golang. And we generate essentially for generic objects, we generate CRUD methods: create, query, update, delete. So you have full persistence layer management. But for token objects, we generate life cycles such as issue or mint, transfer, regular transfer or escrow-based transfer, and then burning and so on. So here's a template that we use specifically for fungible tokens. You see the type defined here, token of the asset, and then within anatomy we specify fungible fractional token, and here behaviors. So this is a kind of tokens that are typically used in digital currency applications, and we generate all of the behaviors necessary to support those operations, including roles. You can then add custom properties of any sort, and then custom methods as well. And we'll go ahead and generate this set of methods ready to deploy together with the APIs necessary for your applications to interact with those methods. So set up in terms of initializing the token system, creating accounts, adding roles, and then issuing tokens, transferring, hold, execute, release, and burning tokens as well. And so this is essentially generated out of the box. You can start with a template, you can quickly tailor it to your particular needs, generate and deploy this, and start exercising those methods through APIs in a matter of minutes. What we generate essentially is a token SDK first, and this is SDK that supports token taxonomy framework behaviors as well as ERC 721. It also has a custodial wallet capability based on accounts. We then have additional wrapper functions that we generate, 30 plus wrapper functions that manage the token lifecycle and make it easier to interact with it and query variety of information. It's got security built in at the functional level. It also has the ability to extend the ERC 721 data model to make the tokens more dynamic. And then we have role-based security built in as well. That can be extended with fine-grained knuckles, but at the beginning you can define roles for minters, burners, notary, and so on. And then there is capabilities to extend if necessary. So all of this is generated out of the box. You could use it directly through the REST APIs, or you can extend it with a custom chain code methods in the same chain code, right? So you could create more complex business logic on top of this, or you can invoke it from another chain code, right? So you might have a modular system where you have other chain codes and then invoking these sets of capabilities. So under the covers, what does the process looks like? Well, you start with a template, as I mentioned, specification file. You then automatically generate, you scaffold the project and generate the actual code. Once it's generated, you can easily add custom methods implementations in the chain code. You can deploy it locally. There is local version of Fabric included. You can do testing and debugging in that environment. And then you can package and deploy it both to Oracle blockchain nodes as well as any other Hyperledger Fabric nodes that might be accessed, or because it's all standard packaging. So you have the benefit, of course, of automatic code generation here, but also faster deployment and faster testing. Also, you have readily available REST APIs immediately available for you to test with, and built-in integration with identity management, which is important, obviously, for any kind of security. Now, in the case of NFTs, we have actually went beyond ERC 721 and provided a number of additional benefits, which I think are critical in enterprise use cases. First, of course, it's a permissioned blockchain network that we deploy on, so there is no gas involved, much less energy consumption, CO2 emissions, greater performance, confidentiality, etc. We have built-in custodial wallets that I mentioned, the account system that we support, so users don't need to worry about managing their private keys if they don't want to. Our NFTs are more dynamic, so you have custom properties that any current owner can update. There is also metadata, which is extended, and the minter, somebody who actually creates an NFT, at that point they create, before they transfer it, can add variety of data based on the application needs into the NFT as well. Built-in security, I talked about role-based and function level security, ability to burn NFTs, which ERC 721 does not provide, but here you can actually destroy or terminate NFT. Built-in API functionality, REST API, and event subscription, so you don't need any third-party external capabilities for that. It's all built in. And all of this ability is generated in source code, provided to you in source code, and templates that you can edit. That means you can easily make this tailored to your particular needs in order to embed in complex applications. You can adapt the SDK code, you can extend the wrapper functions and the like to make this specifically what you need it to be in the context of your application. Now, we've seen a lot of interesting use cases coming up recently since we've announced our NFT support earlier this year. In B2C companies that interact with consumers, like retailers, for example, creating a digital NFT that's essentially an image of a particular physical object. So that enables you to create omni-channel experience in the retail world, VIP rewards, fan engagement, metaverse use cases, traceability of luxury goods, could be jewelry items or other things. We're also seeing use cases in B2B companies that work with other companies, right? So in logistics, electronic bill of lading, which is this negotiable document that has custodians and owners associated with it and goes through the same life cycle. Supply certifications, data marketplaces is a really interesting place now we begin to see for NFTs as well. Traceability of components and products in distribution chains, electric vehicle battery traceability, and so on. Now, a lot of NFTs that you read about today are all about public blockchains, right? That's where most of the users are, and people trade NFTs and so on. But you might ask why you would do this on a permission blockchain network. Well, there are some good reasons for that, right? First, it helps to reduce provenance fraud. There is a lot of fraud going on in open blockchains and open NFT marketplaces. So minting NFT on a permission blockchain on their workflow process and control that's more of a geared to enterprise needs, I think is going to be much safer. You have stronger branding and content control, integration with internal systems is easier, security compliance with enterprise requirements, privacy policies, easier fiat payment integration, and ultimately enterprise-grade capabilities in terms of high availability, performance, SLA commitments that companies like Oracle can deliver. We have also created some solution architectures and playbooks. This is a solution playbook for white-labeled NFT marketplaces that's available on OCI reference architecture. You see here it incorporates a blockchain platform at its core. It's got components to build your NFT marketplaces using Visual Builder that interacts and using ERC 721 chain code with the blockchain platform, content management to actually store the data and documents associated with NFTs, autonomous database and analytics cloud, and so on. So you're going to see, in fact, in Enrico's and Luca's presentation, how they're leveraging this and adopting this particular reference architecture to their needs. Now, if you are interested in building using these capabilities, you can go ahead and get started. But if you prefer a turnkey solution, we also have partners such as TicketCoin and others that can rapidly provide a solution for you. People often ask about how does this interoperate with other blockchains like Ethereum, for example. So we're actually providing an Ethereum interoperability capabilities that will be released very soon that allows us to provide what we call two-phase commit in order to do atomic transfers between tokens in Oracle blockchain and tokens in Ethereum or any EVM-based network. We have extended our API gateway with an Ethereum client and two-phase commit capability. So two-phase commit essentially is a transaction orchestration protocol that's often been used in enterprise systems for many decades. It has very strong safety and liveness properties, and it allows us to basically commit transactions into phases. There is a prepare phase and then a commit phase. But there is also an optimization such that in environments like Ethereum, where you do not have two-phase commit ability, we call it last resource commit optimization, we can actually do a prepare in Oracle blockchain. So, for example, set a token operation. We then do a commit operation directly on Ethereum. We can verify the transaction has taken and then do a commit in Oracle blockchain. Or if this fails, then we can do a rollback. So this allows us to provide a very strong integration. Unlike Ethereum bridging solutions out there that have been bridged, there is no possibility for tokens to exist anywhere in between. They either exist here or they exist here, and two-phase commit takes care to ensure that this is all done atomically. Now, we have a lot of plans actually to further enable this. We are working on additional tokenization capabilities such as ERC 1155 with delegatable behaviors. And you're going to see fractional NFTs. You're going to see also hierarchical NFTs coming out, non-custodial wallet support, exchange methods of various sorts, more decentralization capabilities as well, cross-chain interoperability, not only with Ethereum, but using Hyperledger Cactus as a broader kind of service bus across multiple ledgers, decentralized identity capability with verified credentials, decentralized governance, which is about policies to manage members, and the ability to perform certain tasks such as create channels, update chain codes with asymmetric voting rights, and ability for smart contracts to automate all of the processing around this so that governance operations can be captured as blockchain transactions. And ultimately pulling this together into template-based abstraction layers that you can use to compose either Web3 or typical Web2 blockchain applications around things like decentralized identity, asset tracking, and other popular types of use cases. So let me take a few minutes and share some use cases here. Generally, we see a lot of loyalty use cases around fungible tokens. So it could be retail space, agriculture, supply chain, manufacturing. We also see digital currency and product token use cases with fungible tokens, CBDC, bank digital currency, certified supply chain tracking, insurance ledgers, and the like. And then for non-fungible tokens, things like data marketplaces, provenance-enriched products, where each product has NFT associated with all the provenance information, product life cycles, such as I mentioned for electric vehicle batteries, loyalty programs with VIP rewards. And interestingly, in the last few months, we began seeing interest in healthcare insurance claims being represented as NFTs as well. So here's an example of Decathlon, which is a sports retailer in Europe and elsewhere. They have created a loyalty program in Eastern Europe that's multi-country that allows people to, when they purchase something in a store and walk out, they immediately have loyalty points in their wallet. They can apply them, go to sports club memberships, lessons, game tickets, etc. And this is a very straightforward loyalty case using tokens, but have been very successful because you can do it cross-country, cross-border, without worrying about currencies. Here's an example built by Infosys in agriculture space. So this was in Indonesia for palm oil production. In addition to farm-to-mill provenance traceability, they wanted to introduce an incentive program here that encourages digitization. And so as farmers and cooperatives report more sustainability data, oil mills are providing loyalty points and rewards for every report that they get and variety of activities. This can be used in a wallet to transfer to a bank account as fiat currency, or to actually use directly as loyalty points to purchase certain farming supplies and the like. This is a product tokenization use case here for companies that participates in a fabric textile space. They create and provide chemical ingredients that maintain body temperature constancy in materials. Those goes into fibers and yarns and fabrics and ultimately garments. And there are separate companies that make all of those intermediate products that ultimately roll up into garments you can buy in a retail store. So tracing all of this on a blockchain is much better than what they used to do, which is spreadsheet based. We can do it in real time. You don't have to wait for like end of the month to get the spreadsheets. There is no ability, to introduce any errors or fraud. It's all linked and cross-checked. There is logistic analytics capability implemented on top. You can drill down individual product and see all of the ingredients and sub-ingredients used to make that product. You can visualize the relationships at the product and intermediate product level and company relationships and links as well here. And they're also using fungible tokens to track the royalty payments that all of these companies send them related to the shipment. So we automatically calculate based on the shipment and transfers the actual royalties that are accrued. And then they can, once they get the payments, they can allocate them against those accrued royalties. Here's an example with a long-term customer and partner Everledger. They have a blockchain platform started in diamonds traceability space, and then other jewels. And you see an example here of how provenance data, in this particular case for pearls, from harvesting to certification and manufacturing and so on, is being tracked. For diamonds, they have ability to scan each diamond. There is 40 metadata points that can be captured. They can store the asset with all of the attributes in an asset vault. You have ability to view it. You can transfer it. Obviously, at retail point, you can get digital certificate when you're buying it. once you have an asset in in asset vault, you can easily mint it as NFTs. That's a recent extension of the Everledger platform. The NFT has a provenance data integrated, sustainability data, can be used to verify ownership. You can list it to exchange as well, or you can use it to unlock some unique experiences related to that object. In the insurance space, Supermoney Securus product is addressing issues with insurance accounts reconciliations. There are siloed systems in accounting, and those systems need to be linked together. When you have payments, for example, going between brokers and agents and others in this environment, there is significant manual reconciliation effort and risk of human errors and fraud, impacting both compliance and profitability. So they've created a solution based on a shared ledger where multiple organizations, brokers, underwriters, reinsurers can all participate, and all of their systems are linked together by this ledger so that all of the information is available in single source of truth, and real-time reconciliation is done using smart contracts. CBDC, central bank digital currency, is another great example here. There is a lot of activity in the space. Over 90 countries are exploring, central banks are exploring this, and 10 have now introduced and launched digital currency in the environment. So Oracle has a Sandbox, which you can deploy in the cloud on premises based on our permission blockchain ledger with our fungible token engine included. And then there are applications for regulatory surveillance and oversight on top, currency management, financial crime management, etc. Ultimately, mobile web interfaces and the likes that are available for the central banks, commercial banks, and payment interface providers, financial regulators as well. And you could use this essentially. There's a built-in application that can be extended, but it provides onboarding functionality, money supply management, payment transactions between partners, and of course, fraud prevention, anti-money laundering capabilities as well. Now, I mentioned TicketCoin earlier. So TicketCoin has started with a solution that was used for ticketing and access at certain events. This was for a Christmas event in Italy. There is this beautiful lake where a Christmas tree was laid out in lights, the largest, I think, in Europe. And TicketCoin solution using Oracle blockchain and tokens was used to control access, but it can support a number of other ticketing events as well. But since then, TicketCoin has partnered with OttoOmega to create a new solution capability. And so this is a platform for trading digital and virtual assets on Oracle blockchain. And so let me ask Enrico and Luca to come back and tell us more about that platform.
All right. Thanks a lot. Thanks, Mark, for handing over to us. Very briefly, I'll try to sketch in a few minutes what's our project and why I think blockchain has a role in our project and what's going to change in capital markets thanks to the adoption of blockchain at various nodes of the project. So we are Digital Spirits. I'm the founder of Digital Spirits. I'm the CEO of it. I've been working for many, many years in capital markets. So what we spot as an opportunity in today's fast-changing environment is to introduce in the market a new player, a player that is able to provide digital securities transaction platform on both regulated and unregulated venues, which is very much a big issue nowadays. As you know, probably cryptocurrency has been booming for many, many years recently. But what's missing in the digital currency trading environment is a product related to corporates. And what we believe, and then we're going to see that in the rest of the presentation, the brief presentation, that the capacity, the ability, the capability of treating data can really make a difference in capital markets going forward. So our mission is to create basically trading platform on digital virtual assets. So our partner is TicketCoin, that is partnering with Oracle. And as we are going to see at the later stage, TicketCoin has been releasing to us, thanks to Oracle blockchain, lots of applications that prove to be very useful in our project. So the premises upon which we base our project is that the world is moving towards a full equity transition. Full equity transition means that financial intermediaries and financial players would eventually structure data-driven investment products by not virtualizing accounting measures, but by virtualizing companies' KPIs. Let's say metrics taken out from operational data, not from financial data, and that combines with uh, an expansion of the investment universe that is meeting quite, broadly, a new breed of investors. We all know, we're not aware that generation X, Y, Z would probably never enter a bank. So if these people would never enter the bank, the question is, how can money go to corporates? And this is why we believe that through tokenization and virtualizing data, we can create new financial products that would appeal for those new breed of investors. The evidence is that there are quite a number of systemic drivers that are supporting the growth of digital capital markets: cloud computing, computational power, blockchain, which allows for tokenization. As I said before, the investable universe is moving fast, and from the regulatory side, there is a cautious openness to really understand better what's the phenomenon about. And it's now pretty clear that the regulators would address this issue by captivating the new phenomenon under the regulated umbrella for some products like security tokens, and leave room for unregulated marketplaces and venues and trading venues for products like utility tokens and NFTs that are structured in a way not to meet requirements for financial products. So that opens a new era for capital markets. Mark discussed quite a lot, quite in detail, about NFTs, fungibility, unfungibility, non-fungibility, actually. And so there is a very diverse universe that requires different answers from operational and technological standpoint. But nevertheless, the wheel is spinning. The markets have been known for like a century, where people tend to buy derivatives on, equity is a derivative, debt is a derivative on the assets, on the company, on the business. And now we believe that the abundance of data lakes make really cause a very, very impressive revolution in capital markets that eventually would even entail the digital profiling of investors and also the digital profiling of wallets. So we are now, in our view, we're now facing what we call the quantum leap. The quantum leap is basically new financial products would be data-driven, and the role that capital markets players will have to play is the capacity, the capability of engineering, pricing, and exchanging virtual assets on different venues. So this is what happens. It happens that DLT and artificial intelligence would gather price-sensitive data and publish information. Upon those information, algorithms would price these flows of data, and blockchain would allow for data immutability, transparency, a better information flow with investors, a more timely information flows with investors that eventually may lead to more conscious and appropriate investment decisions. So, just to make a summary out of this first part, the real new element that we want to add to capital markets is not trading. Trading can be very effectively performed also on traditional structures. The real difference is that now corporates and creators really can work upon data flows to build flows, price those flows, and then come up to investors with very very transparent investment products. As a financial intermediary, we have a very, very simple business model, which is creating the products, selecting the products, and make sure that the products that we propose to investors are solid, compliant, transparent. They have a reason to be there. So that requires liquidity, investment research, and a very selective admission process. And the other thing is that investors have to be educated, investors have to be consciously informed, and they have to be evangelized, if you wish, which is making sure they do understand what's the opportunity, what are the risks, and what are the goals. When we started talking with TicketCoin, we said what we need. I mean, we need, in order to do this business, we need lots of technologies, lots of them. Part of them are innovative technologies, part of them traditional technologies. Putting under the same umbrella, regulated operations and unregulated operations requires a lot of equilibrium. So we expect in the first release from the TicketCoin guys or from Oracle, smart contracts deployment, a factory that was able to generate NFTs on demand, the capability to really master data lakes, and eventually the integration of those NFTs or security tokens or whatever, fungible, unfungible digital assets into listings, from listing going into the first auction. And once the first auction is completed, then the secondary market starts. And the secondary market would really make the difference in order to capture and maintain investors' interest into these products, which is actually creating the market. So in order to do this, we needed help. So I handed over to Luca that would tell us what's the high-level architecture on which we are basing our venture.
I'm Luca Mencacci from TicketCoin, and I'm the technical leader for this project. And now I'm going to show you how we are realizing this project and how we are taking benefit from Oracle infrastructure, from Oracle Cloud infrastructure. By seeing this picture, you may notice that the blockchain is the core of our system, because blockchain is the place where we create NFTs and trace their ownership. But Oracle blockchain is also the place where we store data and validate it through smart contract. So that's the most important part, as Enrico told before. The most important part for the project is data, and we store in a blockchain platform. But also we use also many other components of the Oracle Cloud infrastructure. So now let's go through the infrastructure by following, let me say, the data. So data starts from the creators, which enter to the NFT platform, inserts the information about the NFT, for example, like traits, metadata, imaging, and other information content, and then use the NFT generator platform to generate the NFT inside the Oracle blockchain platform. Then the content is immediately stored in Oracle Content Management. And once the NFT is created in a Oracle blockchain platform, then it's immediately synchronized the Oracle Autonomous Database, which is connected by rich history that Mark talks about before. So once the NFT is created, the participating companies could start to send us data for KPIs and for calculating the price of the NFT. And once we receive this data and store it in a blockchain, also this data is pushed to Oracle Autonomous Database, and auditors could start analyzing it using Oracle Analytics platform and using also some dashboard built with Oracle Apex. After that, the traders could start buying and selling the NFTs from our trading platform. And also this transaction is recorded in blockchain platform. And as they are the owners of the NFT, traders are the owners of the NFTs, they can decide to move the NFT also outside our architecture. And in that case, we do an atomic transfer, for example, to Ethereum network, and the content of the NFT, metadata, and imaging are moved to an external EPFS. So the NFT is completely moved out from our architecture, and it can, for example, be sold on a platform like OpenSea. So that's the general idea of our architecture. Then I move. So why Oracle? Because we found a fast and reliable cloud architecture, and we found low-code tools, many low-code tools for build blockchain smart contract, and this give us a very fast and rapid development and allow us to deploy very quickly the NFT as Enrico and the business required. Then we have a seamless integration, as I told you, between Oracle blockchain and Autonomous DB, and this is it's a very boost for analyzing data that was stored in blockchain, for example, transaction or analytic data metric or KPIs we use to the value of the NFT. So also using Oracle Apex, we have reduced time to market. Oracle Apex is very great and useful when we have to do some internet dashboard for the users. And then we have a strong support from Oracle, from many Oracle organizations helped us on design and to build up an enterprise-grade architecture for our challenge. So we have a strong architecture with a focus on security, reliability, and performance. Okay, so now just to show you what's next. We would like to start very quickly with product creation and origination of the product, and then starting from different sectors, from retailers, art, music, sports, and wine. And just to close my contribute, I want to say what we expect from Oracle. Okay, so we expect from seamless integration with the major public blockchain and more interoperability between blockchain and customer data integration layer with corporate. So we can take some the KPI base in a very better way. Okay, so that was my contribute to this discussion, and I hand over Mark again.
All right, great. Thanks very much, Enrico and Luca. This sounds like a very interesting project, leveraging the corporate data flows and KPIs to create new financial products and new products for investors. I'm really looking forward to helping you get this rolled out and see how successful this is going to be in the market in a very short time. So just close here with a quick summary. As you can see, there is certainly a strong interest in tokenization from a variety of enterprise environments. The examples showed earlier, the examples that Enrico and Luca shared. But in the past, implementation of tokenization solutions on permission blockchains was difficult because most permission chains did not have native token support, and the development effort was pretty heavy. You had limited availability of skills required for this and so on. So Oracle Blockchain App Builder helps in three specific ways. First, low-code or no-code approach to applications, which is much faster. It provides support for fungible and non-fungible tokens directly on Hyperledger Fabric with all of the enterprise-grade capabilities. And it also improves developer productivity significantly beyond just development in terms of testing, deployment, and management. So the tooling is going to help companies like Luca's to accelerate this kind of projects from what used to take maybe a year or longer to build down to a few months. Oracle generally has been focused ever since we've introduced this in 2018, making blockchain applications and tokenization applications easy and quick with pre-assembled platform itself, right? The things that we pre-integrate around API gateway, identity management, all of the tooling, rapid development with Blockchain App Builder, the built-in tokenization engines that supports flexible, fungible, and non-fungible token capabilities through SDK, and then a set of APIs and wrapper functions. And even beyond that, we've created some optimizations in Hyperledger Fabric itself to help create greater performance for verification of token transactions and so on. This is a couple sources on how we can help you, our customers and partners, on your blockchain journey. I want to start by quoting Don Tapscott, the author of The Blockchain Revolution, a very important book that actually kicked off a lot of work in the blockchain space. He said, the future is not something to be predicted, but it's something to be achieved. So if you are an SV, if you're in a startup, if you're in an enterprise environment, and you want to try to make a difference, you want to try to build something, there is a number of things we can do. We can help you in terms of a discovery process, work on use cases, helping you to understand in more detail current ones and work on your particular use cases, help you design the blockchain through design thinking workshop, and even have resources to help implement an MVP, a minimally viable product, with our cloud engineering teams and solution hubs and so on. And this is a process that can be done fairly quickly and can get you started on the road to leveraging blockchain. For more information, you can visit our blog, blogs.oracle.com/blockchain. Has a number of posts on NFT support in particular, most recent ones, and many use cases before that. The solution playbook that I mentioned in the OCI Architecture Center is available as well and provides a great deal of detail. If you want to come to oracle.com/blockchain, this is our pillar page. You can learn a lot more, or you can get hands-on and try. You have a 30-day free trial available at oracle.com/cloud/free. And literally, once you sign up, in 30 minutes, you could be using tokens through UI or REST APIs. It's that quick, that simple with the samples that we have provided. For more information, our blog, YouTube videos, documentation, and as I said, you can come into our cloud platform page to sign up for free access and learn more about the capabilities, or download our on-premises OBP Enterprise Edition, which is just a virtual machine download you can run in your own environment. So with that, I thank you and wish you great time at Oracle CloudWorld.